Specimen reception. The Histopathology Laboratory receives both histology and cytology samples. These specimens are received and accessioned at a designated specimen reception counter. Specimen accessioning involves receiving specimens, sorting, allocating a laboratory registration number, and documenting in the specimen reception record book or database. Each specimen should be accompanied by a request form. The specimen should be in a clean, adequately sized container with a wide mouth and a well-fitting lid. The specimen container should be labeled with the patient's name, age, gender, BHT clinic number, ward, name of the specimen, and date of surgery. The information given in the request form should conform to the details on the label. The specimen should be immersed in a fixative. Commonly used fixatives for histology are 10% neutral buffered formalin or 10% formal saline. For cytology, 95% ethyl alcohol is used. The macroscopic cut-up, specimen grossing. The macroscopic cut-up should be ideally done at a cut-up station or a grossing station. If a cut-up station is not available, a well-ventilated and well-lit space with running water and an adequate, flat surface to do the cut-up could be used. The cut-up should be done by the pathologist or a trained medical officer. Each specimen request form and the specimen container label should be checked to see if the information correlates. One specimen should be opened at a time during the cut-up to prevent specimen mix-up. If a dictaphone is not available, the MLT should assist the cut-up by taking down the macroscopic information dictated by the doctor. The instruments used for the cut-up should be sharp, and tissue obtained should be handled gently without crushing or squeezing with the forceps. Tissue samples should then be obtained according to the standard guidelines and submitted into labeled cassettes. Instruments and the dissecting board should be well washed after dissecting each specimen to prevent carryover of tissue. At the end of the cut-up session, the cassettes should be put into the tissue processor. Tissue processing. Tissue processing is the procedure which prepares fixed tissues into a form suitable for embedding within a supportive medium such as paraffin. This is an automated enclosed tissue processor. The specimen cassettes are put into a process chamber or retort, and the reagents are pumped in and out as required. Closed system tissue processors prevent tissues from drying out in the event of a power failure and prevent chemical fumes being released inside the laboratory. Therefore, they enable the processing of samples in a safe and reliable manner. Automated tissue processors comprise 12 to 14 stations. Processing of large specimens take 20 to 22 hours. Whereas 5 to 6 hours are sufficient for smaller specimens, tissue processing consists of 3 main steps. These are dehydration, clearing, and paraffin infiltration. Paraffin infiltration makes the tissue hard. Tissue embedding. Once tissue processing is completed, the tissue cassettes should be transported to the embedding station. Tissue embedding is the process of orientating and mounting tissue in a melted embedding medium. The embedding medium usually used is paraffin wax. The objective of tissue embedding is to form a solid block of tissue to use for sectioning. When embedding, it is very important that the tissue is correctly orientated and that the cutting surface is facing down. Sectioning or microtomy. Sectioning is done to obtain a uniform thin section of tissue that is 3 to 4 micrometers in thickness without changing the architecture of the tissue. The microtome is the instrument used for tissue sectioning. Microtomy comprises trimming and sectioning. Trimming is the process where excess wax on the block is removed in order to expose the entire surface of the tissue. Sectioning is done to obtain a thin slice of tissue ranging from 3 to 5 micrometers in thickness. This section is then put into a 30% alcohol bath. This removes wrinkles that may have occurred on the tissue section. Subsequently, the tissue section is transferred into the water bath and a standard plain glass slide. The slide is labeled using a diamond pencil. The slides are then placed vertically on a slide warmer to drain the water and then to melt the wax, temperature about 65 degrees Celsius, prior to staining. Staining. Staining can be done using the automated tissue stainer or manually. Tissue sections obtained from microtomy are transparent and colorless. The purpose of staining is to color cells and thereby facilitate examination under a light microscope. The initial routine stain used universally is the hematoxylene and eosin stain, also known as the H and E stain. It can be used for different types of tissues fixed in different fixatives, as well as cytology smears. Mounting. Mounting can be done using the automated cover slipper or manually. Mounting is done to protect the tissue section in the slide from oxidation, physical damage, bleaching, or degradation. It enables slides to be preserved for a longer time in storage. Once the slides are ready, they should be arranged on a slide tray and given with the corresponding laboratory request form to the pathologist for reporting. The reports will be available as hard copies or through the hospital information management system. If the hard copies are being used, the relevant persons or units should be informed to collect the reports once they are ready. The signature of the person collecting the hard copy should be taken in the logbook prior to handing over the reports.
Hari.
Once the reporting is completed, the blocks and slides should be filed in block storing cabinets and slide storing cabinets respectively.